The last 2 weeks, we only use command window, which is like your calculator, but a stronger, better version. We plotted stuff, and we can do visualization and other kind of things. Today, I want you to show a different thing using functions and scripts, like you use in C or the language. The problem is, for example, if it's A1, it prints A1, it's P is equal to 2, is equal to something like this, it goes like this, but basically when you enter, it performs execution. Sometimes you want to write all of your codes, run your code, and it will perform the operation after that. In general, all of the program language uses it in that manner. This is like command window. For example, we can do for loops, if statements here, but it's kind of weird. For example, if I can say that if A is equal B, in MATLAB 2 equals is equal, this is the definition. If A is equal to B, then printf, for example, I can say that success, else, for example, else printf B failure fail and okay f printf. Okay, so for example, it gave an error because there's no printf. It should be f printf. Let's do this. Printf else printf. It's not a big deal. And okay, so it printed s. So doing like if statements, for loops in command window is ugly. So we should use something different. And this is the syntax using if, and I will show it in the other window. Okay, so how can we use other kind of things? So there's a new thing here, equals new. So would you like to write a script or function? Functions are like functions that you know in C. They have inputs and outputs. Sometimes they may have voids, like no input, some output, or something like this. But scripts are different. And we will do some stuff with script, and I think it will be fine to use scripts in the first table. Okay, I open the script, and it looks like this. So what can I do? So this is command. It's a percentage sign. So this is my first script. Okay, let's save it. Let's save it to the documents. And I can even view, okay, here, first MATLAB code, something like this, save. Okay. Okay, MATLAB didn't like using MATLAB. Okay, no problem. Okay, save it. Weird. MATLAB is weird. Documents. Like that. First code. I think it will be okay now. Okay, so what can I do? Let's generate a matrix. 1, 2, 3, 1, 2, 4, 1, 3, 9, and 1, 4, 16, or something like that. Okay, let's assume that this is my resistance matrix and change with R, and let's my outputs are equal to like 0, 0.4, 15 or something like that, and my output is like voltages. Assume it's not voltages, R inverse, let's say inverse R times P, and I can write a command here. Here I take the inverse, and always use commands. Commands are good. And by the way, first you can understand what you did, and the one who reads your calls can understand. And this is a culture really important. So resistance matrix outputs measurements, it's not outputs, and this is my V. Okay, so let's run this. So first of all, what was the name? It was first code, if I write first code, it will be wrong. There is no defined function of variable called first code. Okay, so MATLAB is something like this. So this is the directory, and your code should be in this directory, or you should change this. So, or what you can do is, here there's a run function. It says that, okay, it's not in your path. Would you like to add path? So if you run a script using the editor, and if it's not, the new versions, and I don't know how new, suggest you to change the folder. Change the folder. Okay, it's changed the folder. Good. So, there's a problem. Good. Because we have a double dot here. Okay. So let's clear. Write first code. Okay, so I run the first code, it finished. Nothing happened here, but let's look at here. I have B, R, V. I can check B, I can check R, I can check V. So if you write a script, not a function, if you run it, it will basically push everything to the workspace. You can finish your code, then you can continue working using the command window, and you can access each of the variables. But if I write function, I can only reach the outputs of a function. Functions are like dummy variables. But these are like the pointers that can be accessed globally. These are like global variables. So the good thing of the script is like this. So you can simply access all of the variables in the command window. Okay, let's do something different. And for example, what we can do, let's do something with the for loop. Okay, so let's define a resistance from this is resistance matrix, and let's make it generate a dummy 1 to 9. Okay, so
zeros.
Okay, good. I will show you. So what is zeros? And I copy here. Zeros generates an array of zeros with a length of 9. So I call it 1, 9, so it's a row. If I do this, it will be this. Or I can generate 9 by 9 zero matrix or something like that. There is also one's version. Okay. Sometimes it's good to create your matrix first, then move on. Okay. So let's assume that my resistors are like this. R1 is equal to 1. R2 is equal to 2. And let's make a for loop. For loop is like this. For I is equal to 3 to 9. And you put that. Okay, no problem. I is from 3 to 9. So basically this for loop, I starts with 3 and ends at 9. So Ri is equal to R1 plus R2. No, it's not correct. I minus 1, I minus 2. Okay. Do you know what it is? Yes. I basically generate my resistors using Fibonacci series. So R1 and R2 R1 plus R2 is equal to R3. R2 plus R3 is equal to R4, and it goes like this. And we generate some resistances. Let's look. Clear. First code, and R is like this. Okay, so these are my resistances. And let's assume that these are my elements in the A matrix. And let's assume that my first row of A matrix is this. My second row is this. My third row is this. Let's try to implement this. So A1 is equal to R1 to 3. Okay, so what is this? Okay, so A, when I use double dot, it says that use all of the elements in this dimension. And this dimension is the columns in this direction. But this is wrong. I didn't want to use this. So I want to use this. So when I do this, A1 comma, double dot, it basically gets the first row. First element in this direction and all of the elements in this direction. And I do this. So it is 4 to 6, 7 to 9. Let's look. Yes. Okay. Yes, good. Let's see. Clear. First code. No. First code. Let's A. Let's look at R. It's like this. This is here. This is here. And this is here. Okay. So you can do these kind of things with for loops, while loops. So there's also while loop, but I generally use for loops. But it's fine. It's kind of preference. You can use anything. So okay, so let's do some other thing. So I have a new A, and I want to compute new V. Let's assume that it's V2 is equal to yes, V2 is equal to A times, okay, no problem, inverse A. As you can see, MATLAB gave me an error here. It's a warning. It says that it's okay to use in, but it's numerically bad. You should consider using this. This is the pure decomposition. Yep, yes, that's fine. Okay. A times B. Okay, so I have n under V2. Okay, let's run my code. First code, I have V, I have V2. As you can see, they are different. Okay, so let's try to compare these two vectors. So how we can do that? So we can take the difference, V minus V2. Okay, so they are different. So do you have any suggestion how I can compare two vectors, if they are equal or not? So there are some numerical problems, but aside from that, yes, I mean, we can use if, but how can I compare two vectors? Okay, so we can take difference, but these are vectors. So, and I did here, it has 3 elements. Compare if they're same or not, or some other thing. So, or do some. Okay, good, we can do that. Let's try if we can do that. If we can do this, I think we can't. If, let's say, V1 minus V minus, for example, we can do that because it's like printf. Good. We will see. Oops. First code. Okay, it's a different error. No, it's okay. Because it's like if A can be 0. We can do that, right? Okay, good. Say good. Says yes. No, good. So it is just kind of dummy. We can do that. But you will see something weird. Okay, clear. It didn't write, but there could be some numerical problems because they won't be exactly equal. So we can just look at the thing is, the problem, we have 3 elements. So what we can do is, instead of just compare, we can compare each element one by one, or we can take the main difference in terms of the Euclidean distance or something like that. So we can take the norm. So, okay, so how we can take the difference of 2 vectors, or how we can take the distance between 2 vectors. So V1 minus V2 is the difference. So we can take each element, take the square. Yes, good. Or let's make it like this. Okay. So we have 2 vectors, we can take the difference, but it's a vector. So what we can do is this dist is equal to norm. First code, we have this. As you can see, it's back. Let's check if it's true or not. Let's say v1 and v1. We have the first code. Let's look at the dist. It's 0. Okay. So, okay, norm by definition, if you don't have any other variable, computes the Euclidean distance. Okay, but let's look at norm. Have norm. Okay, so norm has different features. So if you write norm x is a vector, which is equal to norm x2, it takes 2 norm, and 2 norm is the Euclidean norm that you know from your classical classes. So it is this, basically. So 2 norm is shown with like this. Is equal to basically square root v1 square vn square like this, or from a linear algebra perspective, it's also equal to this v transpose times v square root. Okay. Good. So what is norm 1? It's called norm 1, which is also simple. V1 is equal to sum of all absolute values. V. Okay. So in order to compare vectors, it's better to compute the distance, and in order to be numerically correct, you can check the distance if it is smaller than some numerical threshold, like 10 to minus 10 or something like that. So let's check this. If norm lower than 10 to minus 5, let's say printf same, else not same, something like this. First code same, they're same. And as you can see, it's kind of ugly, so we can use /n, so it's like C, and MATLAB and C share some similar syntaxes. Whenever C is okay, we come like this, and as you can see, I'm always clearing, which is fine. Yeah, first code, okay, same, no problem, it's same. Okay, so we can use for loops, we can use if statements, and other kind of things. So what? Okay, we have some time. Do you have any suggestion what we should use? Yes. Just randomly. Yeah. Yeah. When things becomes numerical, there's always some thresholds and parameters that you just choose. The problem is these are two different computations. When you take the inverse, it's numerical. They won't be exactly the same. So it's always good adding some threshold. Okay. So what we can do? So we can check if matrix computation is linear or not. Okay, so what I did here is V1. It's my first computation is, what is this? A times B. I didn't take the inverse. Okay, so let's do something like this. So my V1 is RB. Okay, I have A, so let's not change. Okay, so let's delete all of this. So this is my R. This is my B. And okay. So this is my B1. And this is my B2. Let's assume that we are doing superposition method, and B2 is like this: 1, 0.2, minus 1. Okay. So my first output is this. It's equal to pin R1 times V1. Yes. My second measurement is V2, right? Okay. But my original output is this, R times V1 plus V2. Okay. So here what we do is we will try to check if matrix computation or matrix multiplication is linear or not. And let's say we will try to compute V out. Yes, we will do inf R1, and let's make like this. We will compare V out with V1 plus V2, and okay. So as you can see, I didn't use this command that. I leave it here. When you do that, it will publish to the MATLAB command window directly. Clear. First quote. Okay, as you can see, this is my V out, and this is the sum of two outputs individually. So it says that matrix computation is linear, but we know that by definition, but we can check that. And let's try to compute the norm. V out minus V1 plus V2, and as you can see, you can just kind of, the input doesn't have to be a single double. You can use expressions inside of a function. This is important because you cannot do this in C easily. In C, you need to compute the stuff first, then enter as an input. But this is function. This is not just kind of matrix, simple mathematics. This is a function, and this is the input. But input can be also a different computation. Inside this, it computes this first, then enters as an input. And as you can see, the norm is very small. This is in the numerical tolerance of the MATLAB. Okay. So we can do other kind of things, such as like this, times V1, 3V2, and we will compare this with V out to like this, T times V1, 3 times V2. So here, I check the linearity directly using both the superposition and the scaling. So here the input is 2 times V1 plus 3 times V2, and this is my output. Here what I do is, I take V1 is my first output, multiply with 2. This is plus 3 V2, and this is my second output. I will check if they are same or not. And with some, as you can see, they are same. Okay, so matrix multiplication is linear, but it's by definition. And the thing is that all of the linear transformations, even infinite dimensional ones, can be represented using a matrix multiplication.